Okay, everyone. So we're back, and as mentioned, thanks to the magic of video, I have completed the process of isolating my data set down to a single entry per store. And I've done this by looking at the, oops, almost, wait, missed one. There you go. And again, this process that I've engaged in and the way that I did it, right, I went through and deleted them by hand after doing these sorts. This is all the material that would go in your process file, right? Because the other thing that happens, and believe me, this happens, sometimes you miss something, right? And you should always, wherever possible, it's great to have someone else kind of look over your calculations and look over your data set. And as long as you have the process documented, at the very least, if there's an error, you know what point you need to go back to in order to correct it, right? And then exactly what steps you need to do again. So, I know we've talked about sort of what happens after publication, but believe me, these things need to be and should be fact-checked multiple times before they get to publication, and having your process file available then too is also going to be really valuable. So, we're going to do a few things here, and the first one we're going to look at, so we're looking at the so-called sanitation score. Now, the first thing I'm going to do actually, and it looks like this is in order, but we're just going to check as we see a lot of my values are 99s here. I'm going to come back up to data. I'm going to do another sort, and I'm going to sort on the sanitation score, and I'm going to sort smallest to largest. Now, it looks like I was in pretty good shape, but again, always want to double check. And the reason why is because when we are looking at the order of our entries, the order of our values is immaterial when we're calculating the arithmetic mean, but it does matter when we're looking for the median of our data set. So just to kind of get ourselves off on the right foot, I'm going to go ahead and have these sorted so that I can work them that way. Now, I'm going to insert a couple of extra columns here that are going to help me do my calculations. And the first calculation that I'm going to look at is doing the mean, right? This is the one that most of us are familiar with, add them all up and divide, right? So pretty simple process. I'm just going to go ahead and say, now when I'm writing a formula in Excel, the way that I signal to Excel that I'm writing a formula is I start by typing an equals sign. And you'll get familiar with some of the more typical functions from actually, I don't think that has any effect, does it? You'll get more familiar with some of the functions that we use on a regular basis. But for now, we can know that there's one called sum, right? This is going to allow us to sum the values in a set of cells that we can select actually with our mouse or with our arrow keys. And so I type sum and I open a round brace, right? The same way that you would use if you were writing out, writing it out in math, right? You put parentheses around things to sort of show order of operations. And now I can just use my mouse to select. And again, I like to sort of select at the top and then hold down the shift key and select the bottom one. And actually something else interesting happened here where it says 75 rows. So this actually also tells me how many entries I have, which is I'm going to need very shortly. So I've done that. I can just hit the enter key or hit the return key now. And what I have is the sum of all of my values. And if I want to get the arithmetic mean, I just need to divide that. We use the slash to show dividing, and divide that by 75. So, because that's the number of entries that I have. So right off the bat, I've got my mean, which is great. The other thing that I want to locate is my median. And so the median is going to be, once my values are sorted, it's going to be the middle value. Now, I have 75 entries, which means that if I do the quick, it's what, 35... I always have to do the math here. 75 equals 75 divided by 2, right? So 37.5. So it's going to be the 38th value, basically, right? So I'm going to count 37, and then that 38th value is going to be my middle value. The median is the midpoint. So my middle value here is going to be, if it's the 38th row, it's going to be, well, let's find out. This is the kind of visual thing that I sometimes find difficult to do. So 30, oops. 38. Now, because of the nature of my data set, right, I actually know very quickly that the median is going to be 99. But obviously, if there was more variation, I would, I would need that. So I'm going to go ahead and put the median in here. Now, really, I should be labeling these things. So obviously, they're here for sort of mathematical purposes. But I really want to be labeling these actually. So I'm going to go ahead and actually just write that the mean equals 98.2, right? Just doing this as a note. I could do this also in my process file. Median equals 99. Okay, so we now have two options for sort of looking at the central, again, this sort of idea of a central tendency in this data set. But in order to know, in order to still get context, right? So I know that the value 99 is the median, but that doesn't really tell us that much, because one of the things that we want to know is we want to know both what is central and what is very far from central, right? Something that's very unusual. So we have these values of 84 here on a handful of our stores, but how big a deal is it to get a rating of 84? I mean, if we were, looking at a grade in school, that might be like a B or a B plus, right? So, I mean, a 99 is really close to 100. That's really great. But, how bad is 84 by comparison if so many of these stores are getting 99s? And that's where we need to look at some additional kind of descriptors about our data set. And so we're going to look at the measures of spread. And the measure of spread in a normally distributed data set, right? So one that's symmetrical is called the standard deviation. Okay, so let's take a look at what this means. And somewhere here I have, yes, standard deviation. So what does a standard deviation mean? It basically means it helps us understand whether the bulk of values are spread out over a wide range, or if they're very, very closely clustered around that mean value, around that average value. And what's so interesting about this is that we can actually, it is a so-called normal distribution, lets us make predictions or assertions about what percentage of values fall within a certain number of standard deviations of the mean. Why is this important? Well, because we know that if that's what lets us say that if something falls multiple standard deviations from the mean, that it's really unusual. It is distinct from, maybe in this case, if you're more than 3 standard deviations, it is outside of 99.9%, right, of all readings, right? Really, really atypical. Whereas, if it's within 1 standard deviation, that's not really such a big deal. So just by looking at the numbers, we can't necessarily say that 84 is very extreme or really not extreme at all. We have to actually do the math in order to know that. So the way that we are going to do this is we're going to start by doing the calculation by hand. And so you can actually just come to the Wikipedia standard deviation page, and it has a really nice kind of example of how we do this. So for a finite set of numbers, a standard deviation is found by taking the square root of the average of the squared differences of the values from their average value. Now that's kind of a mouthful, but basically what it's saying is we take each reading, we subtract the average from it, and then we square that. We add up all of those squares, and then we take the square root then we divide that by the number of readings and take the square root of that value. So we're going to do this step by step, not to be overwhelmed by it. So we're going to come back to our Excel file here, and in this new column, I'm going to start. I'm going to make this the squares of the difference. Squares of difference. Okay. So again, we're going to use our here, and if I'm doing a formula, I'm going to begin with the equal sign. So the first thing I want to do is, if this is my mean, right, I'm going to say, okay, I want to know the difference between this value minus that mean value, right? So that's simple enough to do. I get negative 14.2. But the great thing about Excel, and any spreadsheet program you might be using, is that it lets us copy and paste these formulas. So I don't need to go down all of these entries. But I want to be clever about this, right? Because if I say do this, what happened there? Well, it's smart enough to know that when I move this formula down one row, I want to be referring, for example, to S3, which is correct, right? Score number 3. But it also moved the other thing, which I wanted to refer to this mean value here. It also moved that down one row, and of course there's text in that one next row down. And so it gets really confused, right? It's like, how can I do math on text? So what we can do to our formula actually is Excel has, and spreadsheet programs have a way to say, this one, hold this value fixed when you're copying this formula, right? Don't actually change this according to the row number, even though I know that's what you normally do. So the way that we do that is actually with a $sign. And so I'm not going to be changing the column, but I am going to be changing the row number. And in order to keep this row number static, I am going to put a $sign in front of it. And then we can see that when I copy this formula down, it will continue to vary the S3, but it will keep that T1 fixed. And so this means that we can then just take this formula, right, and copy it all the way down. And there we have the difference between our value and mean. Now, the other thing that we wanted to do is we actually wanted to get the square of this. So I'm going to use a formula. I'm going to use the power formula in Excel. So I'm going to come back here. I'm going to wrap this in parentheses. And I'm going to say, you know what? I want, actually, yeah, parentheses are handy. So there's a power function. And you see as I start to type this, it gives me a little helper text. So what I want is I want the power of S2 minus T1 to the power of 2, right? I want that difference, and I want it squared. And again, obviously I don't have to copy it all the way down twice. I could have just done it the one time. So then I'm going to put that in there, and I see that's the square of the difference between my value and the mean. Now flipping back to my formula here, and by the way, it's perfectly fine to flip back to the formula, of course. I'm going to get all that, and now I want to calculate the mean of these values and take the square root. So first, to calculate the mean, I of course need to add them all up. So again, I'm just going to, I'm actually now going to use my sum function here, and I'm going to kind of go left and right side with this. So I'm going to say equals sum, right, and I'm going to select all my values. Okay, so that's the sum, and then I'm going to divide it by my number of entries, so I can do that right in the same thing, divide it by 75. Okay, so 11.36, and then I need to take the square root of that, and so I can do, in this case, another equal sign. There's a square root function built in, and I can take the square root of that value. And this right here is going to be my standard deviation. So standard dev equals 3.37. Well, that's all well and good, but what does that really mean? So one of the easiest ways to understand the implications of the standard deviation is to look at something called the normal score, or the z-score. So if we go to the standard score page, what we understand is that basically what I want to then do is I want to express each of my values in each of my readings in terms of the standard deviation. In other words, a score of 84 is how many standard deviations away from the mean. Because if we look at our, if we look at our visualization here, right, it's knowing how many standard deviations from the mean we are that lets us understand how unusual a value is. So in order to calculate the z-score, basically all we need to do is take our value, subtract the standard deviation from it, subtract the average from it, and then divide it by the standard deviation. So I'm going to do one more column here, and I'm going to say I want to take this value, I want to subtract the mean from it, which again I have up here, and I want to divide that by the standard deviation. Oops, that was a plus sign, not a divide. There we go. Okay, now again, I want to fix certain parts of this. I want to hold steady certain parts of this formula. So I want to keep a lock on that mean value. I want to keep a lock on that standard deviation value. But having done this, again, I can go ahead and bring this all the way down. And so what we see from this is, I like to call it the z-score. What we see from this is that the values of 99, obviously we can see just by looking at this data set that they're very common. But what's so interesting here is this 84. This 84 is a major outlier because, again, if we go back to our image here, we can see that having a z-score of more than -3 standard deviations, having a more than -3 or less than -3 properly, right, means that this is a very unusual value. So that's taught us a lot about the meaning of that 84 in context of this data set. So when we come back, we're going to look at applying that distribution idea to a median. So I'll see you in just a minute.